My name is Amit Dhingra. I'm an assistant professor in genomics and biotechnology. You're standing in my lab, which is housed in the plant bioscience, mobile plant biosciences building. We do a lot of genomics and biotechnology work where we are understanding how genes work, and especially physiology tells us, for example, how plants work on a macro level, and we try to use our tools at the gene level to find out what are the genes controlling those physiological processes. Well, I've been working with Matt Whiting ever since I joined WSU because he's got very good physiological models, phenotypic models built up for the last few years. And what was, we could complement all that information by finding the underlying genes. And that's where we've been working for over the last 3.5 years. So when he decided to put this project together, it was a natural progression of events, and we got involved right from the get-go. Well, I'm on the executive committee. That's one part I'm playing in the proposal. And the second one is we're specifically looking at the abscission genes in sweet cherry. And why is that important? The major objective of this proposal is to develop varieties in the future which could be mechanically harvested. Some of the varieties out there, as you know, do not harvest mechanically right now. They are not amenable to our system. But if we are to solve this problem of labor and also come up with new varieties which are desirable, which have all the desirable traits, but we should be able to harvest them mechanically. So it's very important for us to understand, first of all, what are these genes that make a variety easy for mechanical harvesting versus the other that is not. So our objective specifically is to look at the abscission zone. We are going to sample the same region, same tissues for the genes that are working there. So compare the varieties that can have size and do not have size easily. And we'll pass that information on to our sweet cherry breeder, Mendoza or Brucey, who's also part of the project. So this project itself is it goes from field physiology, like Matt's done. We'll look at the molecular data, find the genes, pass it on to Mendoza's program, and then they will develop markers that could be used in the breeding program. I think one of the validation that this is a good idea is that we did get funding. There is a lot of industrial support, and there is a lot of preliminary information building up to this point, where we know there are varieties available that can be mechanically harvested. There is a mechanical harvester already in place. There are physiological models already in place. Now what we need to do is take the next step. That first, for the short term, take this fruit to the market. Make sure the consumer can buy it, consumer likes it, the growers, the processors can grow it, processors can process it. But at the same time, this project is not about solving a problem just for today, for the 4 or 5 years, but we're looking for longer-term solutions as well. Because after 5 years, we don't want to stop making stem-free cherries. And that's where the investment in the genetics part comes in, where myself and Mendoza come together, and building a foundation for the future as well, where we will find the underlying genes for this process, and he will be able to use that information to generate new varieties. For this particular Pacific Northwest industry, it's very important that we stay ahead of the curve if we want to maintain the economic competence. And this is one tool in our hand. We can create good varieties like Bing or Rainier, but make them mechanically harvestable. So we need to reduce costs, of course, in labor issues or harvesting issues. So this is definitely a good idea, and for the industry it means they can sell their cherries safely because nobody's touching them. There's a big issue of food security as well. You don't have any contamination issues. That could be human-borne pathogens passing along. So the industry can go and say, this is a hygienic product, came off the tree directly, with minimal processing. In year one, what we've done is our lab and Mendoza's lab and Matt, all of us have also been sequencing the cherry genome. What that means is we have been developing a genomic blueprint of the sweet cherry, which is already funded by the growers and by WSU. We have international collaborators, other places that grow cherries, they're also part of that group. So what we've done is since we're looking for abscission-related genes or the separation-related genes, we've scanned that genome on the computer right now to look for similar genes that are already found in apple or found in citrus. why citrus is very interesting. It's also non-climacteric, as is sweet cherry. And some of the chemicals we use in our system in sweet cherry are also used in citrus. So this is a very, there are some biological similarities. However, I say this with a caveat, because in sweet cherry you will have, it's a biologically different organism than citrus, so you can borrow a lot of information. But what we've been doing over the last year is basically building a catalog of genes that are related to abscission in sweet cherry using the information we've generated here. And this growing season is when we will start doing the sample collection, phenotyping, to start identifying the genes.